CCI Crash Course. Instrumentation presents episode number 27, two-way solenoid valves, normal, fail-safe and symbols, hook, the switch you cannot see. Have you ever pressed start on a system and heard a crisp click somewhere inside the piping, even though you never touched a valve by hand? That hidden click is a two-way solenoid valve changing state, the simplest, most common discrete control move in industry. What you will learn today: you will learn what two-way really means, how normally open and normally closed bodies work, why normal for the hardware can differ from normal for the process, how to read the little boxes and arrows on a symbol, and how to choose a fail-safe direction that protects people and equipment. Discrete control in plain English. Discrete means on or off, open or closed. In plants, we use discrete elements to isolate fuel, vent pressure, start a purge, or admit air to an actuator. A two-way solenoid has two ports and two states. When the coil is at rest, the internal passage sits in its de-energized state. When the coil energizes, the passage flips to the other state. Two flavors, normally closed and normally open. Normally closed means the valve blocks flow when the coil is de-energized. Normally open means the valve passes flow when the coil is de-energized. The word normal refers to the hardware at rest with no power on the coil. That rest condition is your baseline for reading the symbol and for predicting what will happen during a power loss. Direct acting versus pilot operated. Quick overview. A direct acting design moves the seal with the coil's plunger alone and is common on small lines and low pressures. A pilot operated design uses coil motion to redirect a small internal pilot flow, which in turn moves the main seal. The pilot style handles higher flows and pressures, but usually needs a minimum upstream pressure to operate. The reading skills you learn today work for both styles. Normal for the hardware versus normal for the process. Hardware normal is the de-energized state of the valve body. Process normal is how the plant usually runs day to day. Those can be different. For example, a fuel shutoff valve might be a normally closed body, safe when de-energized, yet the plant may run with the coil normally energized, so fuel can flow during normal production. You may see tags such as normally energized or normally de-energized on drawings near the coil to tell operators how it is typically run. Why the fail-safe direction matters. When power fails or an emergency stop is pressed, the coil de-energizes and the valve returns to its hardware normal. A fuel gas line should fail closed. A relief vent on a purge system may fail open. Your choice of normally open versus normally closed body and your choice of running the coil, normally energized versus normally de-energized, together determine the fail-safe behavior. How to read the symbol like a map. Look for small squares, states, drawn side by side. One square represents de-energized. The other square represents energized. Arrows inside a square show which ports are connected in that state. A small spring symbol shows which state the valve returns to when de-energized. A small coil symbol shows the state you get when the coil is energized. If the ports are numbered, think of port 1 as pressure, port 2 as outlet, and port 3 as exhaust on three-way types. For a two-way valve, you will see two ports with a clear open or blocked path in each state. Start with the de-energized square, trace the arrow, and ask, if we lose power, which ports connect or block? That answer is your fail-safe. Field example: purge air to an analyzer. Imagine a two-way solenoid feeding purge air to a gas analyzer enclosure. If you want the enclosure to keep purging during a power loss, you would choose a normally open body, so air still flows when the coil drops. If you want the purge to stop on loss of power, you would choose a normally closed body. The symbol tells you which outcome you picked before you ever touch the hardware. Checklist for technicians. Trace the tubing and label which port is the supply and which port is the load. Jog the coil from a safe test circuit and listen for the change in state. Confirm the de-energized path matches the symbol's spring return square. Add a small tag near the coil that says normally energized or normally de-energized if it is not already clear. Verify the fail-safe direction supports the process hazard analysis. Common mistakes to avoid. Confusing. Normally open hardware with a coil that is normally energized during operation. Assuming pilot-operated valves will move with no supply pressure. Forgetting that a drawing might show the hardware normal, while the written procedure expects a process normal that is different. A quick history nugget. Long before software took over, discrete air and electric controls ran entire plants with nothing more than relays, coils, and small on or off valves. Early solenoids enabled reliable remote operation of burners, purge lines, and safety interlocks. Those traditions live on in the symbols you read today. Wrap up and what is next. Two-way solenoids are the foundation of discrete control. You now know how to decode normal, read the state boxes and arrows, and choose a fail-safe direction that matches the hazard. In the next episode, we will expand to three-way and four-way valves that route pressure and exhaust for pneumatic actuators. And then we will connect these ideas to motor starters and interlocks. Thanks. Special thanks to Tony Koopelt and the open source community for the incredible free curriculum that powers Crash Course Instrumentation.